What if machines could reason like humans? We're racing toward that reality. It's called artificial general intelligence. The question is, can we build it safely? Hello, you're listening to Where What If Becomes What's Next from Carnegie Mellon University, where we ask the bold questions that become innovations for the betterment of humanity. I'm your host, Randy Scott, and welcome to the podcast. Today is the second of our two-part conversation with Dr. Zico Kolter. As head of the Machine Learning Department at Carnegie Mellon University and a newly appointed board member at OpenAI, where he chairs their Safety and Security Committee, Dr. Kolter isn't just observing AI's evolution, he's actively guiding it. In our first episode, we explored the foundations, how Carnegie Mellon is shaping the future of machine learning, and how Dr. Kolter's work at CMU and OpenAI, the creators of the popular ChatGPT, is addressing the fundamental challenges of AI safety and security. We discussed why this technological moment is unlike anything humanity has faced before, and we examined the 4 critical categories of risk that keep experts in this field awake at night. Now, in this second part, we're going deeper into the specific challenges and concerns that are emerging as AI becomes woven into the fabric of our daily lives. We'll tackle deepfakes and the erosion of trust, privacy in an age of AI agents, and the question of bias in these systems, and the psychological impact of human-AI relationships. And we'll look ahead to AGI, to what the next 5 years might hold, and to the question that ultimately matters most. How do we build a future where artificial intelligence safely serves humanity's best interests? So, Dr. Kolter, let's dive deeper into some of the specific challenges facing AI development. I want to start with one of the most visible problems: deepfakes, misinformation, and the erosion of trust. This seems to be one of the most damaging byproducts of AI's rapid growth. How do you see this unfolding, and what can we actually do about it?
So certainly this is one of, I think, the most visible effects of AI right now. And I have a lot of thoughts about this, which are not necessarily coherent, but I'll mention some anyway. The first thing I'll say is, let's be aware of the fact that propaganda misinformation has existed for a very long time. Arguably, it was kind of all that existed for most of humanity, right? All you had was the word of sort of the leader of your current tribe, right? To tell you what reality was outside the confines of your immediate space. For most of human evolution, that was the situation that we evolved in. There has been a very, very brief period where we had what we felt was kind of external validation through these mechanisms like photos and videos. Those are very, very new, right? In the course of history, humans have not evolved to sort of trust pictures or trust video. It's this narrow slice of time which we've had this supposedly trustworthy validator of external truth. And I think that it is very possible that, what will happen is that we will have to kind of go back to much more the situation that we kind of evolved in, which is that we trust people not based upon evidence presented to us, but based upon our trust in people. I would actually say this is already happening. I don't think this is a good thing, to be clear. I don't think this is a positive thing, but it didn't take AI to erode human trust in media and things like this, right? Our trust is already well eroded when it comes to media. And so will AI act as an accelerant? Yes, probably. It probably will, because we just have much more ability to create completely fabricated videos and things like that. And now real video, of course, that will just be claimed to be fake by people trying to cast doubt on it. And so, yes, it will accelerate our erosion of trust almost certainly.
Can AI or media technologies themselves be a part of the solution?
I do think that there are also technological solutions that may improve that. Things like actual signatures from cameras and stuff that sort of provide a technological trail to say this is actual real video captured that was captured here at this place that, at this angle that looks like it's actually the scene being filmed, et cetera. But the reality is this going to fix the psychological sort of tribalness of humans and our tendency to listen more to people that are in our tribe? Probably not, right? And I'm using that term very, very colloquially there, to be clear. Probably not. Probably people will continue to agree with things that they already agree with. There's lots of evidence this already happens. I hope AI can be on some level kind of a neutral player here in this space, but I think we need kind of globally to develop social structures and policy and government and other ways of building trust, because the current mechanism, well before AI, was already showing massive cracks.
So how do we guide the next generation through this landscape? Let's say if you're talking to a 5-year-old today, what would you tell them? Don't trust anything you see, only trust the people you know personally?
I think that there are still reputable sources of truth out there. I think a lot of media publications do a very good job of vetting and validating what they publish. I think that there is a real value for broadcasters as public goods, right? That sort of does validate truths before they put them on the air and things like this. And, people are debating that now, I guess. They're claiming that a lot of traditional media is actually itself kind of biased and therefore untrustworthy. And you could argue there are biases, by the way, in the information presented to us. That is certainly true. But I also think there is a huge amount of work being done to validate the truth of what's put in front of us in most major publications. It is not just blatant fabrications. And I do have young kids. I have an 8-year-old and a 10-year-old, and I tell them to basically trust sources, learn to build a web of trust when it comes to the sources and the content that you believe. Don't just believe any link you find on the internet, and certainly don't believe any video or person talking on social media, and not necessarily your friends either, because their friends can also be influenced by things. Build a web of sources you trust, informed hopefully by the broader views of society, and go from there. And really, that actually is not that different from the right prescription for a very long time, right? This is actually very good advice 50 years ago too. And I think it's remarkably persistent in how good of advice this is in terms of building a largely factual worldview.
Now let's shift to privacy. The more we use AI for personal productivity or work, the more information these systems accumulate about us. We're handing over enormous amounts of personal data. As you mentioned in our earlier discussion, there's the risk of AI sending emails in our name, whether for malicious purposes or even benign ones, without our knowledge. How do we protect our personal data in this environment?
I want to make two sort of distinctions here. Every major chatbot that is out there with paid accounts, you can turn off data collection for them, right? So you can set the option, and I do in most of my AI systems. To be clear, I don't know that everyone wants to do this, right? I mean, sometimes you say, no, I'd rather my conversations get better, be able to be used to sort of, at a very high sense, help build better AI systems. But you can absolutely delete conversations. You can remove them. You can turn off data collection for the purposes of training. And every major AI system has that option. And if this matters to you, you should absolutely leverage that option. That is very different in terms of privacy than the thing I was talking about, which is sort of sending emails on your behalf. The bigger concern that I have is that AI acts as a risk vector to exfiltrate private data, the data that you are trying to keep private, that you do not give anyone authorization to use. If we start using AI agents to handle a lot of our sort of daily lives, then this is a potential attack point for people to extract that information. And that is definitely a concern, is one that we are very actively working on. I think also, in the relatively short term, we actually will come up with pretty good solutions there, because exists the massive sort of incentive to do so. But I do want to emphasize that these are not the same thing, these two categories of sort of data use. I think a lot of people have this notion that if you type anything into a chatbot, then the chatbot forever remembers that and will share that with anyone else it is interacting with. And that is just not true. That is not how AI systems work. And that is not kind of the mechanism by which they are built. So it's important, I think, to understand the differences here, understand what the real risks are, and understand sort of that at least to me, the risks come much more in sort of the integration of AI into all of our lives acts as another attack vector for people looking to extract information, not that somehow that in the normal course of operation and training of AI systems, your data is being sent to everyone else.
That's an important distinction because as a user, I've been assuming that everything I feed into these systems is helping train the AI, that it's all going into some public cloud of data and information. Is there any truth to that?
At a very high level, in many default settings, some of your behavior will inform kind of the overall, how people use AI, not any of the details of content, right? But again, if you don't want that, you just go to your settings and turn off, using my data for training, and then it will not be used for that, right? So it really is up to you, and you have the decision whether or not you want your data to be used in that way. And that is not in any way a default kind of character of AI that is unchangeable in terms of how it's used.
So that connects to another critical issue, data scarcity and model training. There are concerns that we're running out of data to train these AI systems, that unless we digitize every YouTube video and find entirely new sources of information, we'll hit a wall. Are we at that kind of inflection point? Do we need fundamentally new approaches to make AI smarter, more accurate, and more capable?
There's two answers to this. There is a sense in which a lot of the easy data available on the internet has been absorbed by these systems, has essentially been read by these systems, and therefore, there's not another internet to go after, right? But this is not actually in any way a blocker to progress. This is not some shocking fact that we didn't see coming. What's happened in light of this is a few things. First of all, there's been a massive investment in synthetic data, and for a lot of technical reasons, synthetic data absolutely has the ability to further knowledge and create new knowledge, right? If you spend a lot of time kind of reasoning through something and come out with a summary of that long thinking path of the end, that is new knowledge. That is something you've created, and this is how people create new knowledge. And there's no reason why an AI system can't do the same thing. And in fact, that is exactly what's happening in a lot of modern systems. They are creating new synthetic data that is then being used to train the models. And there's no catch there. This does work as a process, and it is already and it's already being used and already improving model performance. And that's actually a cause for a lot of improved performance on models in recent years. So number one. And number two, as you mentioned, this is arguably true for text data, but it's nowhere near being true for other modalities of data. So when you think about video and speech and images and just we're nowhere close to having ingested all of that. And really, arguably, that's going to be the most useful information going forward, because as we expand from just chatbots to agents to systems that do maybe eventually act in the real world, we're going to need exactly that kind of data. And so I think we're just the data availability, while it's a technical challenge that needs to be addressed, it is by no means a blocker to progress.
But even if we have enough data, do we have the infrastructure to even handle it? Are our data centers, our energy systems, our computing resources adequate for what's coming?
So certainly compute infrastructure, the associated sort of the chips themselves and just getting enough chips made, as well as building the power infrastructure to actually run all those chips, that is a massive technological and sort of logistical and industrial challenge that we will face if we want to really get as much value as possible out of these systems. So there, you're completely correct. Scaling up the infrastructure to meet the projections of demand for AI is going to be the great industrial challenge of our era. And this is not going to be easy. It will require work kind of across the entire spectrum of industry. And, we are talking about massive scales here. And, it is something that will require absolute coordination to do.
And to Dr. Kolter's point about the need for scaling up the infrastructure to meet the future demands of AI. Shortly after our interview, OpenAI announced its plans to design and deploy its own chips in partnership with Broadcom, a chip maker in San Jose, California. In fact, OpenAI and other AI tech leaders such as Amazon, Google, Meta, and Microsoft are planning to spend hundreds of billions of dollars on AI data centers, chip making, and infrastructure by the end of this year alone. Well, this seems like a good place to take a quick break. And when we come back, we'll talk further with Professor Kolter about the challenges in AI's rapid development and what he sees for a safe future of AI.
This podcast is brought to you by Carnegie Mellon University. Located in Pittsburgh, Pennsylvania, CMU is a private, international research university, consistently ranked among the top universities in the world. Its trailblazing research is focused on creating, defining, and accelerating the future of artificial intelligence. For more information, please visit ai.cmu.edu.
Welcome back. You're listening to Where What If Becomes What's Next from Carnegie Mellon University. We're talking with Zico Kolter, head of the Machine Learning Department at Carnegie Mellon University and a newly appointed board member at OpenAI, where he chairs their Safety and Security Committee. Zico, energy consumption by AI is becoming a critical issue, both for environmental impact and for raw availability. I know Carnegie Mellon has been leading initiatives around this challenge. Can you speak to what's being done to address the energy demands of AI?
I have been involved in various times with a lot of the work going on in energy and AI at CMU. There was recently a summit on AI and energy on campus, and we're hosting another one later this year. And all I will say is I think there is massive potential for the research that we do here at CMU to both enable this paradigm shift of sort of how energy is used and where it's used and what powers data centers where and all this kind of stuff. And then also, the sources of energy we use to power these data centers, right? Which can vary massively in their efficiency and their emissions and their effect on their environmental effects, as you say. AI can play a massive role in kind of shaping that as well.
Okay, can the AI models themselves help manage this energy challenge? I've noticed some platforms are now offering less intensive versions of their models for basic tasks. Does that actually make a meaningful difference?
I would emphasize that, the differences in models as they are right now and, selecting which model you use and using a smaller model for a normal chatbot application, the net effect on these things in terms of energy consumption is very, very small. I would not over optimize these things. It feels to me similar to, the drive to unplug all your chargers when they're not charging something, which is not wrong advice. There is a bit of power drawn by a wall wart that's just plugged in, not charging anything, but it is tiny compared to the overall energy consumption that we have as a country. And there's this great book by David Mackay, one of my sort of heroes in this space. And he sort of talked that there's this notion that every little thing helps, right? When it comes to energy, every little thing helps. But a better motto is if everyone does a little thing, then we'll only accomplish a little. And so, look, when we talk about AI, we're not talking about sort of selecting your model, or rather, in the minor case, people intentionally selecting a little lesser model. That's not going to be the big driver here. The big driver is going to be the overall efficiency we have of models, kind of broadly, especially when models become much more autonomous, take many more actions, kind of in long chains on their own. That's where the sort of power scaling becomes much more important.
So let's talk about bias. There are legitimate concerns that AI systems carry built-in biases based on the data they've been trained on, that their answers reflect the world as it was captured in that data. How can we develop AI that doesn't perpetuate or amplify these biases and unfairness?
I think in this case, this is sort of a common point that this man, and to be clear, it is absolutely true that, of course, AI is a mirror of the data that is used to train it. However, one of the sort of amazing things about AI is that what emerges from this is, in fact, a generally intelligent system, or at least I would characterize it certainly on some level, a generally intelligent system. And those systems can then self-reflect and rephrase their training data. And in fact, a lot of data used to train systems now is actually analyzed first by another LLM to assess it, right? And so I think that a lot of these notions of bias, at least characterized that way, these were actually much more obviously prevalent to a certain extent in sort of older, more classical supervised learning systems, that just use a whole bunch of data to train, say, a classifier on whether someone should receive a loan or not. And it's a very different type of model you have there for statistical bias in that setting than you have in an LLM, where the resulting behavior is really not anywhere nearly as immediate a consequence of just certain facts in the training data as you would have for traditional machine learning systems. And so is it an issue? Yes, definitely. Again, machine learning systems are large language models, AI systems. They are mirrors of the data used to train them, but it's a much more sophisticated problem than that. And I think that if, just asking current models, you will see that it's not as if they're the biases that you might worry about most from training data. They're very nuanced in those systems, and they have a lot of nuance around these issues.
Okay, let's address something more intangible, but increasingly important: the relationship between humans and AI systems. There are concerns about vulnerable populations, particularly teenagers developing potentially unhealthy relationships with chatbots that might reinforce both positive and negative behaviors without the judgment or boundaries a human relationship would provide. How should we be thinking about this human-AI relationship?
So this is a hugely consequential issue, first and foremost, and one that we as a research community and OpenAI and many others, they just published an article on sort of teen usage and how we think about sort of changing policies for teen use. Hugely consequential. I think it needs much more attention. It needs much more participation across the spectrum from experts in all these fields to come to a better understanding of what is really the right path forward here. Whenever there's new technology like this that is adopted at this rate, and there haven't been. I mean, social media was sort of adopted in a similar way, but whenever there's a massive adoption of technology like this, there are always sort of effects on people. We definitely need more attention and more work spent in assessing this, and more importantly, in bringing together kind of experts across the board to really understand what are the issues here and what are the best mechanisms for solving them.
So for the final part of our conversation, I want to look ahead. What's next for AI? One concept dominates these discussions: AGI, or Artificial General Intelligence. Some see it as the holy grail that will transform AI from a useful tool into something extraordinary. Others see it as the trigger for catastrophe, the moment we hand over reasoning itself to machines. First, can you define what AGI actually is? And second, is it coming, and what might it look like?
There's a lot of definitions of AGI. It stands for artificial general intelligence. I think that some people will qualify this as basically human level intelligence. Some would say no, it's intelligence that does the majority of economic work that humans currently do. And some would say it just means general intelligence, and we already have general intelligence. So this is already the thing we have. If you assume that AGI kind of means some mixture of all these things, I think we're very close to this, right? Just think about the generality of current models, about the amount of work they can do, about sort of how capable they are. I think it's hard to argue that, if we look back 15 years and see what we had now, these are things that we probably would have called AGI at the time. Do they make silly mistakes? There's this term called the jagged frontier, which is sort of indicating the fact that these systems are amazing in many situations, but also kind of very oblivious in others. And there are certainly gaps in sort of what we think of as basic human intelligence these systems do not have, like their ability to sort of adapt and continually learn and continually update themselves in a sort of specialized fashion for your particular use cases, stuff like this. But these are all problems that are being addressed, and I think we get there.
Okay, so when we get there, will AGI be good or bad?
Now, in terms of sort of, is this going to be a good thing or a bad thing? Again, I'm fairly optimistic about this. I think the net positives do exceed the negatives, and more importantly, these are just things that are, this is a technology that, for lack of a better word, just the progress is already ongoing, right? It's already being, as a world, in some sense, we have basically committed to building this, right? This is the plan. And I think doing things like, we should absolutely invest everything we can to ensuring that AGI, in the sense that we are currently developing. So if you don't believe that to be AGI, and if you just don't want to use that term, that's fine. But I tend to use that term. And I think that the thing we should be doing is really focusing on building it in a safe and manageable fashion. That should be our goal.
Also wondering, will AGI arrive suddenly? Like, will we wake up one morning to find that some company has released a model that changes everything overnight? Or is this more of a gradual evolution?
I think it's going to be a gradual evolution. I think it was not clear that would be the case maybe 10 years ago, but I think what we've seen is very much this is a gradual evolution, yeah.
So let me ask you this as we close. What's your vision for the next 5 years? What does healthy, safe AI deployment look like to you?
Predicting 5 years in the future is incredibly hard, which is crazy to say, but it just really is. I mean, 5 years ago, I never would have thought we are going to be where we were now. So 5 years, who knows where we're going to be in 5 years? However, all I can think about right now is sort of given what we have currently, what are the best, most important things to work on? And at least right now, I think those things are ensuring the systems we are building right now act as safely, as securely as possible, and just ensure that we are able to build a set of immediate AI systems that accomplish our goals and actually further the aims of humanity rather than somehow acting contrary to those.
Thank you for this conversation, Dr. Zico Kolter, and the critical work you're doing. So that concludes part 2 of our episode. And that also concludes season 2 for Where What If Becomes What's Next from Carnegie Mellon University. It's been a memorable season 2. We've had inspiring discussions with CMU faculty, researchers, and innovators on their bold work in areas ranging from quantum science to theater arts, from robots picking apples to the future of gene therapy, from game theory to the science of sound. Now, if you've missed any of Season 2's episodes or you want to explore our podcast archives, you can find them at cmu.edu/what's-next-podcast. I'm Randy Scott, and you've been listening to Where What If Becomes What's Next from Carnegie Mellon University, where we are asking the bold questions that become innovations for the betterment of humanity. Stay tuned and stay curious.